Okay. All right. So again, we are going to talk about simultaneous equations. Okay. Let's start off with an example. Let's say you have 4x plus y equals 1. This is the first equation. And the second equation is 7x minus y equals minus 12. This is the second equation. So in this question, again, the statement says solve the pair of simultaneous equations. And in order to do so, you need to just think about a suitable method. Now we can clearly see that if I add 1 and 2, I would be able to do it by elimination method. But today we will talk about the second method, that is called the substitution method. Okay. So what do we do in substitution method? I'll tell you. Okay. I'll just take any of the two equations. Let's say I take equation 1. Using equation 1, I will make y the subject of the equation. That basically means I'll make y separate. I'll take all the other numbers and variables on the other side just so y is separate. So this is 1 is 4x plus y equals 1. Now this 4x is being added here. It's positive 4x. So I am going to take it on the other side and it would become y equals 1 minus 4x. So what is this? This is the value of y in terms of x. Next, I am going to consider equation 2. That was 7x minus y equals minus 12, and I will use y equals 1 minus 4x in 2. Okay. So when I will plug in y equals 1 minus 4x, what would happen? I'll plug in the value of y over here, and this would give me 7x minus y is 1 minus 4x equals minus 12. And now when I will make x the subject, this would become 7x minus into 1 would make it minus 1, and then minus into minus 4x would become plus 4x equals minus 12. 7x plus 4x would give me 11x. And I am going to take this minus 1 on the other side and it would become minus 12 plus 1. Okay, that minus 1 became plus 1. And finally, I am going to get 11x equals minus 11. So this would imply that x is equal to minus 1. Now this is the value of x. Using this value of x over here, I would get the value of y. So y is equal to 1 minus 4x. So this means it would be 1 minus 4 into, instead of x, I'll write down minus 1. And this would give me 1 minus into minus would become plus 4. And this would give me 5. So the final answer is going to be x equals minus 1 and y equals 5. Okay, let me just go through the entire working again, and then you will get a better understanding of the topic. Okay, so this is basically again about solving the pair of simultaneous equations, and you guys can use any method. It's completely fine as long as you are easily able to find the value of the unknown variables. Okay, so whenever the statement would say solve an equation or solve the pair of equations, this would mean you need to find out all the variables. And how do we do that? By making the variable the subject, right? When I say the subject, I'm basically supposed to separate the variable on one side. I'll take everything on the other side, and then I would get the value of the variable. But if you have two variables in one equation, things are not easy. And this is what basically simultaneous equations are. So today, we are talking about the substitution method, and substitution is self-explanatory. We are going to use one of the two equations to make one of the two variables the subject. For example, equation 1 was 4x plus y equals 1. I've used equation 1 to make y the subject, and I got 1 minus 4x. Once I had the value of y in terms of x, I've plugged in the value of y over here, and upon simplification, this was basically an equation with one variable only, and all of us know how to find out the value of a variable when there's just one variable in the equation, right? Let me just admit, Musa. Okay, all right. And then I was able to find out the value of x, and once I had the value of x, I can use this thing right here. I've plugged in the value of x, and this gave me y equals 5. So the final answer was x equals -1 and y equals 5. Let me do two more examples, and then things would get better. Just relax and don't worry, okay? Don't worry. And you guys can certainly do the same question using elimination method, but you need to know both the methods, okay? You need to know both the methods. Okay. Let's talk about another question, question number 2. Okay, so here you have 3x plus y equals 23, and then you have 3x minus 2y equals 17. This is equation number 1. This is equation number 2. Again, the question is same. Solve the pair of simultaneous equations. Okay, fine, fair enough. Now, in order to solve this, you need to understand a few things, okay? First of all, I need to understand which method would be ideal. Now, technically, when I will look at this pair, I can see 3 and 3 is same. I can certainly go by elimination. I would be able to cancel 3x with 3x, and I would get an equation with y only. And that method is also possible. But let's see how exactly can we solve this using substitution. So step number 1 is to make one of the two variables the subject of any equation. Okay, for instance, in the previous equation, I made y the subject, and then I plugged in y in the second equation, and I was able to get an equation with x only, and things were easy. But this time around, if I try making x the subject, what would happen? Let's see. Okay, again, I can choose any equation. Let's choose 2 this time. Okay, using 2, I can see it's 3x minus 2y equals 17. Okay. Now I need to make x the subject because I need to substitute x in the first equation. Substitution method may we will be substituting x, okay, or substituting y. Anyways, so let's make x the subject. So I'll take this on the other side. Here it's being subtracted. So it would be added here. 3x equals 17 plus 2y. Next, 3 and x are being multiplied. So I'll take 3 on the other side, and this would give me 17 plus 2y, and it is being divided by 3. So this is the value of x in terms of y. Okay. Next, I need to use this value of x over here, just so the entire equation has x only. So you will understand this in a minute, okay? Use x equals 17 plus 2y divided by 3 in equation 1. Okay, so in the beginning I've used equation 2, I made x the subject, and now I'll use equation 1. I'll plug in the value of x and let's see what happens. So equation 1 is 3x plus y equals 23. I need to use x in equation 1, so this would give me 3. Instead of x, I'll write down the value of x, that is 17 plus 2y divided by 3 plus y equals 23. Next, 3 and 3 can be cancelled, okay? And I am left with 17 plus 2y plus y equals 23. Like terms can be added. 2y plus y would become 3y and 23, and the 17 would be taken to the other side, so it would become minus 17 because here it was being added. So 3y is equal to, so just 223 minus 17, and this is going to give you 6. So this implies that y is equal to 6 divided by 3, that is 2. This gave me the value of y. Now in the beginning, we know what exactly x is in terms of y. I can plug in the value of y here and this would give me the value of x. So use y equals to, in x equals 17 plus 2y divided by 3. This would give you x equals 17 plus 2 into 2 divided by 3. And this is going to give you 17 plus 2 multiplied by 2. So this is 17 plus 2 multiplied by 2 would become 4 divided by 3 would become 21 divided by 3, and this is going to be 7. So this is the answer. So finally we got x equals 7 and y equals 2 as the answer. Yes, anything that's coming to your mind, any query, any other suggestion?
No questions.
Ariba, Hassan, Musa, Noor, Rabia, Urva?
No, ma'am.
Okay. Are we guys good with this? Are all of you there?
Yes, ma'am.
Yes.
We are good.
Okay.
Yes, ma'am.
Okay, perfect. Okay. So let's talk about one more question and then I'll talk about some past paper questions. Or I think let's just shift to past papers now. That is more better. Okay. So let me just cross this. Okay, now in this PDF, you guys will get to see a variety of questions from different topics. We started off our discussion with solving linear equations and fractions. So we will practice all of that content over here along with some problems related to simultaneous equations. So let's get started. Okay. Now this is question 8 of some exam and it says solve 4 divided by x minus 11 equals 1 by 3x. The statement says solve. I've been telling you guys already, whenever the examiner is telling you to solve an equation, he is expecting that you will be able to find out the value of the variable, that is x. Okay. So how do we do it? So you have two fractions here with an equal to sign. All of us know what exactly
Ma'am,
cross multiply.
cross multiply.
Yes, very good. We will cross multiply. Excellent. Okay. So I am going to cross multiply at this point. So 4 multiplied by 3x is equal to 1 multiplied by x minus 11. Okay. 4 multiplied by 3x would give me 4 multiplied by 3 is 12x. And then we would have x minus 11. I need to keep x on one side and I need to separate the other number on the other side. So I am going to take this x over there and this would give me 12x minus x equals minus 11. This is 11x equals minus 11, and this would give you x equals minus 1. This is going to be the answer. So you'll write it down as minus 1. Do not forget to write this value over here, okay? Yes. So please remember that whenever you have something of this scenario, you can do it. For example, let's say this wasn't the question. You had some other question. 4 divided by x minus 4 divided by 11 equals 1 by 3x. Just assume that this was the question. Now, what do you guys think? Are we supposed to cross multiply here?
No.
Very good. Why?
No, ma'am. Ma'am, because there are two equations on one side.
Yes, because there are two fractions on one side. Very good. Well done. Okay. Always remember, you can cross multiply whenever you have one fraction on the left side and one fraction on the right side. Here we have two fractions and here this is one fraction. So what we need to do is just take the LCM on the left hand side, make it one equation, and then you can cross multiply. Okay. So just know you cannot cross multiply for this scenario. Okay, we'll come across such questions, then I'll tell you in detail how exactly are we going to solve them. Anyways, let's talk about the next question. Okay. All right. Something very important related to fractions. Acha. Express each of the following as a single fraction in its simplest form. Okay, now what is happening? We have a plus sign here and we have a divide sign here. Okay, all right. First of all, just look at the two fractions. It's 2 divided by 3a plus 5 divided by 2a. Now, you can see that you have two fractions with a plus sign, so certainly you'll have to take the LCM. How do we take the LCM of these variables? I'll tell you, okay? Do not think about it as something very, very complicated. It's not complicated at all. So here we have 3a and here you have 2a, okay? So first of all, you can take a here, right? Both of them can be divided by a because it is 3 multiplied by a and it is 2 multiplied by a. This would become 3. This would become 2. Next, I can go with 2. This would become 3 as it is and 1. And then I can take 3, 1 and 1. And the LCM is going to be a multiplied by 2 multiplied by 3. So this would give me 6a. I'm pretty sure that you guys were not able to understand this thing. Let me explain this again. This time around, we have a plus sign, and I'm pretty sure by now you guys would be knowing that you cannot directly add the numerators, you cannot directly add the denominators because the two denominators are different and you have a plus sign between them. So what do? We need to take the LCM. We know that we have been talking about it, but how do we take LCM of such variables? So think about 3a multiply and 2a as simple multiples of a. A is a number, right? And first of all, I've taken a out and this would give me 3 and 2 and then 2 and then 3. And at the end, the LCM turned out to be 6a. So it's going to be 6a. So what number do I multiply with this 3a to get 6a? I need to multiply 2. And if I'm multiplying 2 with the denominator, I need to multiply 2 in the numerator as well because this is maths. Similarly, here I have 2a. What number do I multiply with 2a to get 6a? I'll multiply it by 3. Similarly, since I'm multiplying the denominator by 3, I'll have to multiply the numerator by 3 as well. And finally, I'm going to get 4 plus 5 multiplied by 3 is 15. And this is going to give me 19 divided by 6a. And this was the question as a single fraction, okay, in its simplest form. So I cannot cancel 19 and 6 or a. So this is the final answer. It's going to be 19 divided by 6a. Yes, any confusions with this?
No, ma'am.
Confusions.
Confusions or no confusions?
No confusions.
Okay. Hassan, Muiz, Musa, Noor, Rabia, Urva. Yes, please tell me honestly. You can type as well if you don't want to unmute. Just let
No,
me
ma'am.
know.
No confusion.
Okay, I hope that you guys are clear with it then. Okay. The second question is 5 divided by 2b square, division sign, 15 divided by 4b cubed. Now we know we have two fractions with a division sign. How do we deal with it? This is the most interesting case. So the first fraction comes directly, okay? This is 5 divided by 2b squared. Then division sign, we don't know how to deal with division sign. So I need to change the division sign to multiplication. And as I've been telling you guys already, this is maths and I cannot do anything by my choice. Since I've changed division to multiplication, I need to take the reciprocal of this fraction as well. And this fraction is going to become 4b cubed divided by 15. Now let's cancel out stuff. So b squared can be cancelled and I can do it like this. And then it's 1 times and it is 3 times and then it's 1 times and it is 2 times. So I am left with 2b divided by 3. Very good, Ariba and Muiz, excellent. Okay. So the answer is going to be 2b divided by 3. And this is the correct answer. Okay, so I hope that you guys can clearly see the difference. In the first fraction, we had a completely different way. For the second question, we did something completely different. Why? Because for the first one, we had a plus sign. For the next one, we had a division sign. And we know that according to the sign, the method is going to change. Okay.